Good day everyone, I am Marisha Altea Di Milana, and in this video, I will be explaining my solutions to the given trigonometry problems. I will read each problem, show my solution, and explain the steps clearly. We are given a right triangle where the opposite side is 6, the adjacent side is 6, and the hypotenuse is 8.49. Before solving, I noticed that the opposite and adjacent sides are equal. This means the triangle is a 45 to 45 to 90 triangle. In a 45 to 45 to 90 triangle, the hypotenuse is equal to 1 leg times the square root of 2. So, 6 times square root of 2 is approximately 8.49, which matches the given value. Now I solve for the trigonometric ratios. Sine is opposite over hypotenuse. So, sine P equals 6 over 8.49. To simplify, I rewrite 8.49 as 6 times square root of 2. So this becomes 6 over 6 square root of 2. Canceling out the 6, I get 1 over square root of 2. Rationalizing, this becomes square root of 2 over 2. Cosine is adjacent over hypotenuse, and since the sides are equal, cosine P is also square root of 2 over 2. Tangent is opposite over adjacent, so tangent P equals 6 over 6, which is 1. Cosecant is the reciprocal of sine, so it is square root of 2. Secant is the reciprocal of cosine, so it is also square root of 2. Cotangent is the reciprocal of tangent, so it is equal to 1. Next is item number 2. We are given cosine of angle equals 6.71 over 7. Using the Pythagorean theorem, I solve for the missing side. Opposite squared equals hypotenuse squared minus adjacent squared. So that is 7 squared minus 6.71 squared, which gives approximately 2 as the missing side. Now I find the other trigonometric ratios. Sine angle equals 2 over 7. Tangent angle equals 2 over 6.71. Cosecant angle equals 7 over 2. Secant angle equals 7 over 6.71. And cotangent angle equals 6.71 over 2. Next is item number 3. A point is 70 meters from the base of a tower, and the angle of elevation is 35 degrees. Using tangent, which is opposite over adjacent, tangent over 35 degrees equals height over 70. Given that tangent 35 degrees is 0.7, I multiply 70 by 0.7. So the height of the tower is 49 meters. Next is item number 4. From a 97-meter cliff, the angle of depression to a boat is 60 degrees. Using tangent again, tangent 60 degrees equals opposite over adjacent. So 1.73 equals 97 over the horizontal distance. Solving for the distance, I divide 97 by 1.73. The horizontal distance is approximately 56.07 meters. For item number 5, I'm strictly not using any calculator right now. So first is we need to find the exact values. For First is letter A. Tangent 60 degrees times sine 30 degrees equals square root of 3 times 1/2, which is square root of 3 over 2. Letter B. Sine 30 degrees plus tangent 45 degrees equals 1/2 plus 1, which is 3 over 2. Letter C. Cosine 60 degrees times tangent 60 degrees equals 1/2 times square root of 3, which is square root of 3 over 2. Next is item 6. We are not again using any calculator here. In a right triangle with a 45-degree angle and one leg equal to 6 centimeters. Since it is a 45 to 45 to 90 triangle, both legs are equal. So the other leg is also 6 centimeters. The hypotenuse is 6 times square root of 2. Now we are on item number 7, which is law of sines. We are given angle A equals 55 degrees, angle B equals 37 degrees, and side A equals 15 centimeters. Using the law of sines, B over sine 37 equals 15 over sine 55. Solving for B, B equals 15 times sine 37 divided by sine 55. After substituting the values, B is approximately 11.02 centimeters. Next is item number 8. We are given triangle AXYZ where angle X is 55 degrees, side X is 15 centimeters, and side Y is 9 centimeters. We are asked to find angle Y. Using the law of sines, I know that the ratio of a side to the sine of its opposite angle is the same for all sides. So I set up the proportion. Side X over sine X equals side Y over sine Y. Substituting the values, I get 15 over sine 55 equals 9 over sine Y. Next, I solve for sine Y by multiplying 9 by sine 55 and then dividing by 15. Since sine 55 is approximately 0.8192, multiplying gives 7.3728, and dividing by 15 gives 0.4915. Taking the inverse sine, I find that angle Y is approximately 29 degrees. Now we are on item number 9. We are given triangle AXYZ where side X is 8 centimeters, side Z is 11 centimeters, and angle Y is 84 degrees. We are asked to find side Y. Using the law of cosines, I know that the square of a side equals the sum of the squares of the other two sides minus twice the product of those sides and the cosine of the included angle. Substituting the values, I get y squared equals 8 squared plus 11 squared minus 2 times 8 times 11 times 0.1. Calculating each part, 8 squared is 64, 11 squared is 121, and 2 times 8 times 11 times 0.1 is 17.6. Adding the squares and subtracting 17.6 gives 167.4. Gives approximately 12.94 centimeters. So side Y is approximately 12.94 centimeters. Now we are on the last item, which is item number 10. We are given triangle ABC with sides A equals 15 centimeter, B equals 6 centimeters, and C equals 8 centimeters. We are asked to find angle A. Using the law of cosines, I know that the cosine of angle A equals the sum of the squares of the other two sides minus the square of side A, divided by twice the product of those sides. Substituting the values, I get cosine A equals 6 squared plus 8 squared minus 15 squared, divided by 2 times 6 times 8. Calculating this, 6 squared plus 8 squared minus 15 squared equals 36 plus 64 minus 225, which is negative 125. Dividing by 96 gives approximately negative 1.302. Since the cosine of an angle cannot be less than negative 1, this means the triangle cannot exist. So there is no solution for angle A because the triangle is impossible. And that is all for my solutions. These answers are based on my understanding and computations. I may or may not be perfectly correct, but I am confident that I did my best and showed my complete solution. Thank you for watching.